Very good morning to one and all. Today, we are going to see a problem on Kirchhoff's voltage law. Take on this circuit. Here, in this circuit, here one voltage source is there. That is 20 volt voltage source is there. Here, three resistance are given. That is, resistance 1 is 3.3 kilo ohms, resistance 2 is 2.2 kilo ohms, and resistance 3 is 1 kilo ohm. So, we need to verify the Kirchhoff's voltage law. So for verifying the Kirchhoff voltage law, first we are going to find out the R equivalent since all three resistors are connected in the series. So just we need to add all these three resistors, that is 3.3 plus 2.2 plus 1 kilo ohms. So if you add all this in, the equivalent resistance will be 6.5 kilo ohms. So since it is all in kilo ohms, what I'm doing is I'm just taking out the values alone and finally I'm adding kilo ohms. Or otherwise, if you want to convert and add also, no issues. So same answer will come. The R equivalent value is 6.5 kilo ohms. Next, we need to find out the current here. We need to find out what is the current here. So current I is equal to V by R equivalence by Ohm's law. So here voltage given as 20 volts. 20 divided by R equivalent is 6.5 into 10 to the power of 3. That is kilo ohms. So if you simplify it, you will get the current value as 3.0769 milliamperes. So this is the current we got it as. Next, the voltage drop across each resistance we need to find out. Voltage drop across every resistance. Like resistance 1, resistance 2, and resistance 3. So the voltage drop across each resistance we are going to find out. So V1 is equal to I into R. I is nothing but whatever we calculated, that is 3.0769. Then the voltage drop for resistance 1 is I into R. So I is nothing but 3.0769 into 10 to the power of minus 3, that is milliamperes, into resistance R1. R1 is 3.3 kilo ohms. 3.3 kilo ohms. So that we are multiplying here. So V1 is equal to 10.15. Next, similarly, the voltage drop across the resistance 2. Resistance to V2 is equal to I into R2. So I already we calculated 3.0769 into 10 to the power of minus 3 into the resistance 2. Resistance to the voltage, the resistance to values 2.2 kilo ohms. Here we are adding the multiplying the 2.2 kilo ohms into 10 to the power of 3. So V2 we got it as 6.79769. Similarly, the voltage drop across the resistance 3. Here we are finding out the current. So current V3 is equal to I into R3. So I is 3.0769 into 10 to the power of minus 3, that is milliamperes, into resistance 3 is 1 kilo. So 1 into 10 to the power of 3. So V3 we got it as 3.0769. Since this circuit is series circuit, here the voltage drop across each resistance will be changed. So here you will be finding voltage drop across resistance 1 is V1. Here we will be finding voltage drop across resistance 2 is V2. Voltage drop across resistance 3 is V3. Like that, we'll calculate the voltage drop across each resistance. But the current, whatever the current we calculate, that will be the constant. That will be flowing to the all the resistance. But here you see the voltage drop between voltage across each distance will be getting dropped. So this is the example for like a serial set lights. It's so all serial like LED lights. Say for example, this you consider as one LED light. This you consider another one LED, third LED light, like that. For festivals, you are using for serial lights. So serial lights, all the resistance are connected in, all the lights are connected in series. So this is the best example. That is resistance connected in series is the best example for the the serial lights. That is that we used in a festival time. So if you see the serial light, that will be some 100 bulbs LED will be there. 100 bulbs LED. So voltage in practical, the voltage we are connecting at as 230 volt AC supply. 230 volt, 50 hertz AC supply we are connecting. So depends on the current, 5 amperes or 10 amperes. There is a calculation. So this many bulbs will be there. It depends on the capacity of the bulb, LED bulb. There will be this many bulbs will be connected to one particular serial light. So that is the calculation. This is the best example for that serial light. Okay. So what is Kirchhoff's voltage law states? Kirchhoff's voltage law states that algebraic sum of all the branch voltage around any closed path is zero. Branch voltage around the any closed path is equal to 0. So Vs is equal to, so or otherwise Vs minus V1 minus V2 minus V3 is equal to 0. Then Vs is equal to V1 plus V2 plus V3. That is this source voltage. This source voltage is equal to voltage drop across the resistance 1 and voltage drop across plus voltage drop across resistance 2 plus voltage drop across resistance 3. So that is the Kirchhoff's voltage law. Here voltage source we are taking as 20 volts. V1 we calculated as 10.15 volts. V2 we calculated 6.769 volts. And V3 we calculated as 3.0769. If you add all these things, you are getting approximately 19.99. That is approximately equal to 20 volts. So this Kirchhoff's voltage law is verified. Here volts I missed. Here you add Kirchhoff's voltage law is verified. Like that, you need to conclude the problem.